If you haven't had the chance to watch the last video, I encourage you to do so to gain insights into creating this workflow. In the meantime, here's where we concluded, and in the upcoming segment, we'll delve into utilizing IPADAPTER for consistent character creation. So, I've loaded the face image that we created in the earlier video as the source image in the reactor face swap. Turn on the face restore model inside the face swap node, as it will further refine the swapped face. You can also minimize the loaded image node by clicking this small gray button here. Alright, so I've loaded these two free images this time for the style reference, which will give us a unique style and pose, and then the final image will be swapped to our consistent face in the reactor face swap node. Let's set weights to these images. I'll try equal weights to both images. Allow some noise for the IPADAPTER to be creative. Keep in mind, we are using an XL model here, which supports the resolution of 1024. I'll use a vertical resolution here, 768 by 1024. Okay, write the text prompt. Let's Q prompt this. Oh, forgot to connect this. Okay, so here are the results. This is our consistent face image. We are going to generate more images with this face. We'll call this face Maya, who is a complete nobody. Okay, so let's create some more images of Maya. This time I'm using these two completely different images. I've included a third image here for the background. The background is not going to be exactly the same, but it will take some reference from this image. Let's give some weight to the background image. And this time, I'll use my favorite sampler so far, UniPC Bahi 2 with Karas. We'll do a comparison video of these samplers in a future video. For now, let's Q prompt. Okay, let's see what we've got here. The quality of using this sampler is noticeably better than Euler. Let's look at the image closer. Yeah, it's Maya's face. Let's compare it with the reference images. Nicely blended. The background is not picked up too much by the IPADAPTER. We'll try a higher weight to the background next time. Let's try creating some more images of Maya. I've already loaded these two free images and a background image. Let's set the weights. I'm giving more weight to the first image than the second image this time. We can play around this if we don't like the result. Lower the weights of the overall IPADAPTER node. Otherwise, the text prompt will be completely ignored. We'll use HoneP2 sampler, which is blend of two samplers, HuNN and DPM2. This is great for realistic skin details with less artifacts, but the generation speed gets slower with this sampler. Let's run this. Let's see what's wrong here. I forgot to load the IPADAPTER here. Let's load IPADAPTER plus SDXL. For IPADAPTER plus, you need check this switch here, otherwise you will get an error. Okay, the results, impressive. Background is from the reference image. It's not perfect this time, but you got the idea how to do this. The quality of the image is impressive. I don't see any artifacts. Even the hands look pretty okay. This image only needs a pixel upscaler now if we want to upscale it to, let's say, 4K. So let's say I want different pose for this generation. For that, I'll use ControlNet. Let's add a ControlNet node here. The ControlNet model I'll use is OpenPose XL. Make sure to download ControlNet XL model because we are using an XL checkpoint here. I'm using DW preprocessor here to extract the pose from load image here. Now I've set a resolution of 1024 in DW preprocessor. Set the same resolution in empty latent image. Otherwise, I've noticed that the image starts to get a little weird. Let's drop a preview here to see what we are getting here. Lower the weight of the control net a little. Okay, let's proceed with this. We've extracted the pose from this image using the DW preprocessor. Now here's the result displaying the loaded pose. However, it's not ideal. You can observe issues with cropping and the image appears a bit unusual. Nonetheless, on certain occasions it produces excellent results.